All right, gang, put your goggles on because we are about to dive right into the process of wireless communication. Now, I want you to remember, wireless communication is much more like back in the day when we would connect a couple of devices together and they would be maybe a part of a hubbed network or maybe a part of a bus network, a coax network. In those environments, whether there was a hub or whether we were off of a bus, essentially we operated very primitively. We used something called CSMA CD, Carrier Sense Multiple Access with Collision Detection, as defined in 802.3. Now, that specification said for a wired Ethernet network, only one of us can speak at a time. If any of us try to speak at the same time, our packets will collide. So let's carrier sense, let's listen to the wire, and not send anything while someone else is talking. Then as soon as someone's not talking, multiple access. We can jump on and we can send something. But you and I both might have heard the nothing and then both tried to talk at the same time, which means there's a possibility of collision. So there's collision detection. If we detect a collision, we back off, we try again. That's 802.3. This isn't 802.3. Gang, you're in a wireless class. This is 802.11. And the specification here is CSMA-CA, Carrier Sense Multiple Access with Collision Avoidance. Let's try not to actually have a collision. This is going to take a little more brains to make it happen, but very cool stuff. Collision avoidance deals with the same problem. We have shared air. Only one of us can speak and we can only send or receive. We can't do both because that would be a collision. So that means half duplex communications for wireless. The process looks a little something like this. First, recognize that we're going to be using what's known as a DCF, a distributed coordinator function. What that means is there's no central access point determining who's going to talk and who's not going to talk. Although that's a possibility, it's never implemented. What we're going to have is every device on a wireless network is responsible for their own ability to send a message without colliding with anybody else, without triggering a collision. So this begins with a device that wants to send a frame. All right, it's ready to send a frame. Yay! But someone else is using the network. Remember, we did carrier sense. If someone is using the network, I can't use it yet. So anytime there's any message going out on the network, we're going to wait what is known as a DIFS. This is a countdown timer. And this is the standard countdown timer called a distributed interframe space. Basically, buffer out our frames one from another. All right, so I'm waiting for that to happen.